Hello viewers, my name is Jeff Odual and this is Chemistry Now. Now tonight we want to look at this topic, the atom. The atom. Now first and foremost, let us look at the subtopics that we look at in this topic today. Today we want to look at the definition of an atom. Then we want to look at the structure, general structure of an atom. Then we look at subatomic particles, the particles within an atom. Then finally, we look at the atomic number, mass number, and isotopy. So straight away, let us define an atom. What is the definition of an atom? Now, an atom is defined as the smallest particle of an element that takes part in a chemical reaction. The smallest part of an element that takes part in a chemical reaction. So you can write it down. Is the smallest particle of an element that takes part in a chemical reaction. Now, it is the atoms that react. It is the atoms that knock each other in a reaction to form new products. So that one gives us the definition of an atom. Now, the next thing we want to look at is the structure of an atom. So when you're talking about the structure of an atom, you're talking about general structure of an atom, because we know that atoms differ from one element to another with regard to maybe atomic radii and so on and so forth, the number of electrons, number of protons, as you will see later. But tonight, let us look at the general structure of an atom. Now, we can demonstrate that by drawing. So, all atoms have a center. I can draw it a little bit bigger than that. All atoms have a center, and the center of an atom is referred to as the nucleus. The nucleus. Now, the nucleus is the center of the atom. That nucleus is surrounded by what we call energy levels. Energy levels. So this is the nucleus, which is the center of the atom. Then the nucleus is surrounded around by rings known as energy levels. Now, that one brings us to what is in the atom, because in the nucleus, there are certain particles in the nucleus. In the nucleus, we will find what we call protons. Protons are denoted by P+, P positive. I'll be able to demonstrate and to explain why we use P+ or P positive. Then inside the nucleus, there is another thing. There are particles known as neutrons. I'll demonstrate it by N0. I will explain why. So we have protons in the nucleus. We also have neutrons. Neutrons in the nucleus. Now, in the energy levels, we also have substances, or rather particles, that are found around the energy levels. So these particles, we can demonstrate them using those X's. Now, the particles that are found around the energy levels are referred to as electrons, and they are denoted by E, like that. So these ones are electrons. So this is the general structure of an atom. An atom will have a center, which is known as the nucleus. The nucleus of an atom contains protons and neutrons. Then the energy, the nucleus is surrounded by energy levels, and in the energy levels you will find electrons. So these ones are electrons found in the energy levels. So this is the general structure of an atom, and I believe that is very clear. So that one brings us to the next thing that we want to look at tonight under the atom. We want to look at the subatomic particles. Now, subatomic particles is what we've just mentioned here. So the subatomic particles, we have the electrons, we have the protons, we have the neutrons. Now, I'll demonstrate them in form of a table. I will draw a table, and then that table will be able to show the properties of these subatomic particles in terms of their charge, in terms of their mass, if they have. Then we look at the locality. Where are they found? Then I believe that it will be very clear. So let us have a table. We can have a table where we have the three subatomic particles, because we have learned that the subatomic particles are the protons, they are electrons, and they are neutrons. Now, to show their property, I want us to have a simple table. That table will have the particle, the subatomic particle. They are small particles found within the atom. So under these, we know that they are three. We have one, and then final one. Then under these particles, we want to look at the charge. The next thing, what is their charge? The next thing we want to look at is what is the mass of these particles? The mass. Then we want to look at locality, their locality. Where are they found within the atom? The locality. Then now we start with the first one. We can start with the proton. Or rather, let us start with the electron so that the chart flows properly. Let us start with the electron. The electron. Now the electron, I denote it by E negative. That is an electron. Now then you can have the proton. Proton you can say is P plus, positive. Then finally the neutron. The neutron you can see that is N0. Now the charge on an electron is negative. So electron has negative. It has a net charge of -1. So one electron has a net charge of -1. One negative. So all electrons are negative in nature. They have a negative charge. The protons are positive. Protons have a net charge of positive. So you can say P plus. So one proton has a net charge of 1 positive. Then when you come to the neutrons have no charge. You can say that, or you can say that they are neutral in nature. They are neutral. They have 0 charge. That is why a neutron is denoted by N0. They have no charge. So that is the properties of these subatomic particles with regard to the charge that they hold. Then let us come to the mass. Now electrons have negligible mass. That is, their mass is infinitesimally small, that their mass does not affect the general property of an atom. So you can say that the mass of electron is negligible. Is negligible in reference to the atom and other subatomic particles. The mass of an electron is negligible. It is infinitesimally small. It does not affect the general property of an atom. Now, the proton has mass. Proton has mass. And the mass of a proton is denoted by a +1. For instance, one proton has a mass of 1. One proton is noted to have a mass of 1. Then neutron also has mass. Neutron has mass. So neutron also, one neutron also, there's one proton, one neutron also is noted to have a mass of 1. One neutron, one unit of mass. Then we come to locality. Now, before you look at locality, you can see that the mass of an atom is determined by the protons and the neutrons in that atom, because the mass of electron is negligible. Now, locality, we have seen that electrons are found in the energy levels. Energy levels. That is where the electrons are found. That is where they are located. Now, the protons, we have seen that the protons are found in the nucleus. That is in the center of an atom. The same as the neutron is also found in the nucleus of an atom. So this is the general property of the subatomic particles. So we are learning that the protons and the neutrons are found in the nucleus, and they're the ones with mass. So the mass of an atom is concentrated in the center, in the nucleus, because the energy levels around the atom have electrons which have negligible mass. So basically, the energy levels around an atom is like a free space. So I believe that is clear. Now let's look at another thing. We have looked at these subatomic particles. There are things that I want us to note before we go to the next. Now, I want you to note that one, it is worth noting that the number of protons in an atom, number of protons in an atom is always equal to number of electrons in the atom. At any given time, the number of protons will always be equal to the number of electrons in that atom. So if you have 10 protons in the nucleus of an atom, you are sure to have 10 electrons around the energy levels of that atom. So for this reason, the atom is electrically neutral. Why? Because if you have 10 positive and 10 negative, you will get 0. So we can say that therefore, the atom, or rather an atom is electrically neutral. Atoms are neutral in nature. Why? Because the number of protons and the number of electrons are the same, so they cancel each other. Then another thing that we have noted is that the mass of an atom is determined by the number of neutrons and the number of protons. So I believe that that is very clear. Now, I want us to look at the next thing. We have looked at the structure, the subatomic particles and their properties, and then now I want us to look at these numbers, the atomic number, the mass number, and finally we'll finish with isotopy. Now let us start with atomic number. Atomic number is the identity, is like the identity number of that particular atom or element. So if you find that something, the atomic number is maybe 16, you are able to relate that number to only a certain element. So let us define atomic number. Let us just wrap this and start with atomic number before we move to mass number and isotopy. So atomic number is defined as the number of protons, the total number of protons in the nucleus of an atom. This, excuse me. So atomic number is the total number of protons in the nucleus of an atom. So this is the definition of atomic number. Somebody would want to ask, why are we not using electrons, yet electrons and protons are the same in an atom? The reason why we don't use electrons to define atomic number is because protons are permanent. Protons don't change. Electrons may be lost or may be gained, but protons will remain the same. So protons is what is used to define atomic number. That is, the total number of protons in the nucleus of a substance or in the nucleus of an atom is its atomic number. So for example, if you have an element, X, let's say an element, just an example, element X has maybe 8 protons. It shows that the atomic number of X is 8. So the number of protons in the nucleus of an atom determines its atomic number. So I believe that is clear. For example, if you come across an element with let's take for instance 8, like we have said, then you just know straight away that element is oxygen, because oxygen has 8 protons in its atoms. So that is very clear. So then we come to the second number, which is mass number. The second number, which is now mass. This one, which is mass number. Now, mass number, from what you've learned about the subatomic particles, the mass of an atom is determined by neutrons and protons. So that one gives us the definition of mass number. Mass number is defined as this is the total number of protons and neutrons in an atom. You can say in an atom or in the nucleus of an atom, is all okay. So if an atom has 8 protons and 9 neutrons, then the mass number will be 17. Example, if an atom has, let's say, 8 protons and 9 neutrons, then the mass number will be equal to 8 plus 9, which is equal to 17. The mass number of that particular atom is 17. So I believe that is straightforward. So the numbers that we've learned today is the atomic number, which is the total number of protons. Then another number that we've learned today is the mass number, which is total number of protons and neutrons in an atom or in the nucleus of an atom. I believe that is clear. Now, before we move to the isotopes, I want us to have a table here. You may encounter these maybe in an examination. So you can have several elements or atoms of a given element. We just have an example here. So we can have this maybe element. We can have element. These are not symbol of elements, but just example. Maybe W, X, Y, Z. We can have this. Then first we can have number of protons. Number of protons. The next column we can have number of electrons. The next column we can have number of neutrons. Then we can have here atomic number. Then finally you can have mass number. You can have mass number over there. Now suppose these elements, this one has maybe atomic number 9, this one has atomic number 15, this one has atomic number 20, this one has atomic number, let's say 17. Or maybe you can put it as smaller number, maybe 7. Then that column is left. Then somebody tells you that the number of neutrons here is maybe 8, or rather, let us put it as 9. Then atomic number is left, mass number is left. You have to fill these spaces. Then here, you're given mass number here to be 31. Then this part is left, this part is left, this part is left. Then here maybe you're given the atomic number, maybe as the atomic number is not given. You're given the number of neutrons here again. Maybe you're given here as 21. Then you fill the rest. Then finally, here you're given the number, the atomic number you're given, and then you're also given the number of neutrons, maybe as 7. Then you're told to fill what is left. Now, from what you've learned, you should be able to fill all this, because one, we have learned that the number of protons and the number of electrons are the same. So if you have 9 protons, the electrons must be 9. Then we have also learned that atomic number is the number of protons in the nucleus of an atom. So here must also be 9. I'll use blue. Excuse me. I'll use blue there. Then you can be able to work out the mass number, because mass number is the number of protons plus the number of neutrons in an atom. So that is 9 plus 9, which gives us 18. So that is how you fill that table. Now, when you come to X, you have 15 protons. You have the electrons are not given. This one is definitely 15. And then the number of neutrons you are not given, but you're given the mass number. So this plus this is equal to this. So the number of neutrons must be 31 minus 15, which is, so the number of neutrons must have been 16. Then we can jump to the last one. We have 7 protons. So definitely electrons are 7. And given the number of neutrons also are 7. So the mass number of this particular atom Z will be 7 plus 7, which is 14. Then we have this Y. You can work it out and give your answer in the comment section. Now that is clear. The next thing I want to look at is isotopes. What are isotopes? What is isotopy? So, but before we look at isotopes, I want to look at something. We have learned about the mass number and we've learned about the atomic number. Now, there's a way the mass number and atomic number is represented in a periodic table. You look at periodic table is a topic that will come later. But if you have an element X in a periodic table, suppose X is an element, this is just an example, then a number will be written here. A number will have a number here, Y, Z. Now this number that is written here is the mass number. This one is always the mass number of that particular element. Now then down here, this one is usually the atomic number. For instance, you'll find oxygen, element oxygen written as O. Then up here, you may find a number. For instance, if it is you may find here written 16 and here 8. So this 16 is the mass and 8 is the mass number. This is the atomic number. So that is very clear. Now the next thing we want to look at is we want to look at what we call isotopes. Now, isotopes are defined as atoms. You must use the word atoms when you're defining an isotope. So, isotopes are atoms. They are atoms of the same element. Your definition of an atom must start with this statement. They are atoms of the same element with same atomic number. Same atomic number. Atomic number, we say that is the number of protons. Same atomic number or number of protons with the same atomic number, but different mass numbers. Somebody might want to say, but different number of neutrons. But let us have it this way for now. Now, all atoms of a given element all have the same number of protons, because I said earlier, the number of protons do not change. That is what is used to define atomic number. They don't change. But the number of neutrons may vary. You may find an certain atom X has 10 protons and 10 neutrons. But then there's another atom with 10 protons. You see the protons are still the same, but number of neutrons in the second atom might be 11. So maybe one has 10, 10, another 10 and 11. Protons 10, 10 neutrons, 10 protons in another, but 11 neutrons. So that disparity in the number of neutrons, you can see that it must affect the mass of that atom. So the mass numbers differ, but the atomic number is constant. So if you encounter such atoms, they can be 2, they can be 3, they can be more. If you encounter such kind of phenomenon, then that is referred to as, those are referred to as isotopes. And that occurrence of isotopes is referred to as isotopy. So isotopes are atoms of the same element with the same atomic number but different mass numbers. Now we want to look at examples of isotopes. Examples of isotopes. We want to look at 2 examples. We have carbon. Carbon as an element exhibits isotopy. We have carbon 12 and carbon 14. Now carbon 12, we can have it as a table like this. Carbon 12, if you look at the number of protons, P positive, now you know that that is protons. Then the number of protons in that, then the number of neutrons, N0. Then we look at we can put atomic number. We can have mass number. All right. So carbon 12, the number of protons in carbon 12, carbon always has 6 protons in its nucleus. Number of carbons in carbon 14, protons the same because the atomic number is the same from the definition. But the number of neutrons now vary. So carbon 12 has 6 neutrons, but carbon 14 has 8 neutrons. Then atomic number is 6 because atomic number is the number of protons. But the mass number here will be 12. Mass number here will be 14. That's why it's called carbon 14 because it is 6 plus 8. So I believe this is very clear. So these atoms, you can see that this is an atom, this is an atom. They're all atoms of the same element carbon with the same atomic number but different mass numbers. So they are called isotopes. And if you are to present them in a periodic table, like if that to be presented properly with their atomic number and mass number, then this one will be C12, then down here 6. This one is C14, 6. So that is very clear. Another example is other examples that you can have other than carbon, you can have chlorine. Another example is chlorine. Chlorine also has 2 isotopes. We have chlorine 35 and chlorine 37. Chlorine 35 and chlorine 37. If we have to look at it the same way, now chlorine 35, chlorine has any atom of chlorine will have 17 because chlorine is number 17 in the periodic table. It is atomic number 17, same as this one. So this one is we can say these ones are protons, neutrons. You can have here atomic number. You can have here mass number. Now the neutrons, the protons here is also 17 because the number of protons is constant. The number of neutrons in this case in chlorine 35, the number of neutrons in chlorine 35 is 18. Atomic number, while in chlorine 37, now chlorine 37 has 20 neutrons. Chlorine 37 has 20 neutrons. Now the atomic number in this case will be the same, 17, here 17, because atomic number is the number of protons. The mass number here, you can see that if you add 17 and 18, you get 35. Here, if you add 17 and 20, you get 37. So this one is chlorine, 35, 17. This one is chlorine, 37, 17. So these two are isotopes, atoms of the same element with the same atomic number but different mass numbers. Or you can put it that they're atoms of the same element with the same number of protons but different number of neutrons. So this one brings to the end of our topic today. For this and more, you can visit our page, Chemistry Now with Jeff Odwell. Thank you.